My pleasure. Okay, so let's talk about assessment. In research, there's really only about 3 to 5 questions, so we don't spend a lot of time there. We spend most of our time in assessment. Okay. So just in general, okay. So when it comes to assessment, it's really about testing the tools we use, and then it's assessment and testing. So when we think of assessment or the tools, think about, instead of thinking about the waste and the whisk, think about the gas tank in your car, your thing that tells you how much gas you have. That's a tool that assesses something, right? So we always want those tools to be valid. The most important thing when it comes to the tools that we use is, do they do what they're supposed to do? Okay. So reliability is important, but the validity is the most important. Does it measure what it's supposed to measure? And a lot of this is really getting to know the language of math. So a measurement is the how we measure it. The assessment is the tool that we use, and appraisal means it gives it a human judgment. So when you bought a house, there was an assessed price, usually assessed by the state of what it's worth. But the appraiser is actually the person that comes out and he looks at the house and he determines how much it's really worth based on comparison of the neighborhood. So that's an appraisal. Interpretation is literally telling you what this test means, what the score means. Okay, so when you take your test and you get your tests back and it tells you what areas that you miss, interpretation is, I only missed by 2. I interpret it by, you still miss almost half. Okay, so we're trying to look at what the test means. My measures of central data, again, central tendency, we'll hear that a lot. That's your mean, median, mode. We get that mean by adding all the numbers together and dividing the numbers, right? The median is the number in the exact middle, and the mode is the number that appears the most often. So distribution is that list of numbers, right? So to get my mean, if I've got 5 numbers, I add them up and then I divide by 5. To get the median, I put the numbers in order, like 1, 2, 3, 4, 7, 8, 9, 10, and the number in the exact middle is the median. And the mode is if I have more than one of those numbers. If I have 2 2s, that's the mode. Okay. You can actually have a term called bimodal, or refer to them as boobies, because you can have a distribution that has more than one mode. So if I have a distribution that has like 2 5s, and 3 7s, then I get boobies. Okay. So bimodal means that two numbers appear more than once in your area. Okay. If my numbers are all the same, I have a normal bell curve. The 68, 95, and 99 is the rule. What that means is in any distribution, what that means in any distribution, the majority of people are going to be in the middle. My computer is. So what we know is if there's 1,000 people, if there's 1,000,000 people, if there's 500,000 people, this is how the numbers are going to fall. That most of us are just going to be average. So what we know is the pink, that's in the middle. Everybody loves the pink. That's always my reminder. So 68, 2/3 of the population are just average. If we look at IQ, what we know is normal IQ is 100. It has a standard deviation of 15. That means if we go down by 15, that's 85, and up by 15, that's 115. So a normal IQ is between 85 and 115. So the standard deviation takes into the fact that there may be some error there. Okay, so that's what we mean is just the standard deviation, 68, 95, 99. What that looks like when it's broken down, it takes that 68 and divides it by two separate parts. So what I know is 34 and 34. So one down is 34, one up is 34. Well, two up. So if I use this and I talk about a standard deviation of 5, it's my whiteboard. So what I know then, if I take this same deviation, right, the score we're using, right? So what I know then is with standard IQ, it's 100. So 100 goes here, the exact middle. And it'll tell me it has a standard deviation of 15. Okay. So that means that this is going to be 85. I'm going to go down by another 15 because the question will tell me the standard deviation is 15. So this would be 70. This would be 65. Okay, I go up, I add 15, 115, 130, 145. Okay, so when it comes to a situation like this, what I know is that the normal IQ is 100. So between 85 and 115, we still say you're in the normal range. Okay. If you go up to 130 or go down to 70, then now we're talking about people that are in the special ed category. Okay. So below that is you wouldn't be in school. And if we go here, then what we know is people in this category are my gifted people. So in a school system, they do really well with the people in the middle. However, if you're below 70 or above 130, then that's when you get an IEP, whether you're slow or smart. 145 is going to be Mensa. Those are the people that are extremely smart. Very few people in the world qualify for that category. There's a test you can take to be if you want to be a member of Mensa. Okay, so that's what it looks like. No matter what number they give me, it can be 30 or 60 or 12. No matter what they give me, I know how to figure it out based on the information they're sharing with me. Okay, we'll come back to that. Okay, so what I also know is in a bell curve that I definitely have a skew. A skew means when my mean, median, and mode won't line up. So in a skew, what I know is the mean guy is on top. I'm sorry, the mode is on top, the mean guy is in charge. Okay, so how do I determine if it's a positive or a negative skew? So Tia, do you know?
The top would be the positive and the lower would be the negative. I just know because of the shape. That's how I learn. That's how I remember.
Okay. Okay. So what matters is the number. The mean guy is always in charge. Okay. So ice cream a la mode, mode's on top. So before our standard deviation, everything was in the middle. Right now, the peak is the mode. So if the mode is 30 and the mean, he has the I over him, the mean is 60, is that a positive or a negative skew?
Negative.
Okay. So how do we decide that? So the mode is 30. So that means the mode's on top. Is 60 higher or lower than 30? Is 60 bigger
60
than
is
30? Would you rather have
yes.
$60 or $30? Which is more?
60 is more than 30.
Okay, then that means the mean guy is higher. So the mean guy is going to pull it up. So that is a right skew. okay, or positive skew because it's going up. So it's based on the number. So if the mode was 30 still, and the mean was 15, 15 is lower than 30, right? So it's a negative or a left skew. The mean guy determines which way it goes. It determines whether it's a positive or negative skew. The mode is always the middle. So I'm looking for the mean guy, the mean decide which way we go. That looks confusing. Okay. So talk to me. It's literally a matter of which one is the highest.
No, I actually get it now. My brain used to think it was the opposite because the way it looks.
Okay. Okay. So
But I
remember
get it
though,
now.
just remember the mean is in charge. Okay. So the mean number is in charge. The median, we don't really care about. He goes wherever he wants to go, right? He's not that important. The mode, ice cream a la mode, always on top. The mean guy determines which way we go. Can't say that one. Okay, so the mean is 20. I'm sorry, the mode is 20. That's a 2. And the mean is 10. Is that a positive or a negative skew?
You said the mean is 20 and the mode is 20 and the mean is 10.
10.
It's negative
Because, because
because the mean was lower than the mode.
got it. Okay. Those are facts. Things don't change when it comes to it. Those are just the facts. Math just has facts. Okay. I've been working at my desk like all week, and I'm throwing away like all the cups and the paper plates that I've been working at my desk. So, okay, we're good with that. Okay, okie dokie. So we're gonna take it up the next notch. Let's look at these questions. 1 second. I am just looking for questions. Okay. Okay, see my score, my screen? Have a clue what I do with this question?
These take me out every single time. All these daggone numbers. No. What is this?
Not near as hard as you think. Okay, so I'll click on your chat box. Okay, so read the question for me.
Test A given. Test A has a mean of 500, a standard deviation of 50, and a SE of 5. A student obtained a score of 520. If retested, we would expect his score to fail within which range? About 95% of the time. What?
Okay. So what is asking me is given this student, one student, an SCM is always one student. The standard deviation is the entire group. So all I really want to know is where on the bell curve he would fall 95% of the time. So what I need to know is the test has a mean of 500, a standard deviation of 50, and the error of measurement for the student is 5. All I need to know is what the student's score is. His score is 520. Now, remember when we were over here at the bell curve, when I told you that tells me the standard deviation, I just keep adding and subtracting. So I said on IQ, it was 100 and the standard deviation was 15. So this was 85 and this was 70. This was 115 and this was 130. You see how I got that? Right? If I know the standard deviation, I subtract 1 and I whatever the number it is, I go down 1 or go down 2, depending on what the question's asking me. But in this one, it's his score. I don't need the mean. On the standard deviation, on standard error of measurement, it's the person's score. So I'm going to add and subtract. They gave me SEM. So the first time it would be plus or minus 5 at the 68%. But this is asking me at the 95th percent, which is 2 standard deviations below the mean. So then it's going to be 520 plus or minus 10 because it's at the second standard deviation. If it asks me about the 99th, it would be 520 plus or minus 15. Because that's at the 99th percentile. If it's at the first one, I add and subtract the number they give me. The second one, I'm going to double it. The third one, I would triple it. Okay, so of this score, all I need, this is the SEM. All I need is his score. I need the SC, the SEM, and I need to know what percentile, or they're asking me about. What standard deviation? Are you with me? Yes, are you with me?
Can you break
Yes.
one more time? No.
Yeah, my bad. Go ahead.
Okay,
No.
okay. So what I know is in this question, I'm looking for the SEM. There'll be some questions that ask about the standard deviation, but this one is about the SEM. And I know it because it asks me about a student. When it says a student, it's only looking for that particular student's error. Okay. So of all the information they give me up here, when it's a student, this is all I need. And his score and what it is. Okay. This is SEM. I don't need the bell curve to do this. I am illustrating, but you don't need the bell curve to figure it out. Just because we know, again, this is the middle. This is the first standard deviation. So the rule of IQ, it's a fact. You'll see that on the test. Standard IQ is 100. That's a fact. It's got a standard deviation of 15. Facts. Okay. So then, if this is 100, I know that if I go up 1, the 68% is 115, right? Because I add 15 to it. If I go up 2, it's 15. I'm going up another 15, so this is 130. If it's at the third one, I go up another 15, which is 145. I go down, I know this one because it's plus or minus 15. The first time, that's my 85. The second time, I'm going to subtract another 15. Okay, the third time. Okay, so at the first standard deviation, the 68%, I add and subtract the number they give me. At the second one, I double the number they give me. Okay. The third time, I triple the number they give me. Just facts, just facts. Now, in this particular question, it's asking me about the SEM, which is the student's score. So I don't need the mean. I just need the student score. Okay. So if I do the same thing, and again, I don't need the bell curve to do this. I'm just doing it to help you to illustrate, but you don't need that. You can figure this out in your head. So now I know the student scored a 520. Okay. So I know that the SEM is 5. So this would be 525. $530 and $535. Do we see how I got there? Okay, if I go down, again, I know the first one is minus 5. So this is 515. Minus 5 is 510. Minus 5 is 505. We see where I got the 5 from. Shadia, do you see where I got the 5 from?
Yeah.
Just the question told me. So now I know at the 95th percent, I am here because it's the second standard deviation. So 510 to 530. Okay, let's do another one. Math just has facts. Just facts, just facts. Okay. Don't be scared. It's much simpler than you ever think it would ever be. I promise you. My phone was listening the whole time. So this whole text I just said went in a text to somebody. I have to erase it. Okay. Okie dokie. So what we know is 68% is the same thing as a 2/3, right? Right? Because this is in the bell curve, this is 2/3. The 68% is the same as the 68 whenever I see 2/3. The bell curve is divided into 3. And the biggest 2 of the 3 is the same as the 68%. Okay. So then what I know is that, and again, it's a student score. So what do I need from this question if it's a student score?
Just the score,
Okay, I need the student score.
right?
And what else?
Any, the SEM, SEM.
The SEM. Sometimes it'll say the SE. Okay, so same thing. The student score. And what else?
The SEM, the 3.
Okay, I also need to know 2/3. It's telling me where he is from the middle. The 2/3 is the same thing as 68%. Okay. So what I know then is that my middle is his score, 82. And it says 2/3 of the time. So what do I do?
You add 3 going
And
positive and negative
okay, I'm going to add and take away 3. How come?
because the SE was 3.
Mm-hmm. And it's at the 68th percent or the first standard deviation. So all I know is it's 82 plus and minus 3. Not hard. One second, I'm just looking for some more of those. Okay. Shadia, talk me through this one.
Given test B has a mean of 100 and a standing ovation of 15 and SE of 5. The student obtained a score of 110. If retest, we can expect his score to fall within a range about 95% of the time. So from what we given was that the average score is 110, and we're looking at the 95% of the time, so we're not paying attention to the mean. So we do 110 plus 5 give you 115, but that's not our range. That's at the 68 range. So we add another five with that. So 115 plus 5 equals 120. So we gonna cut off already A and C. So
Well,
we're
what am I adding
between,
and subtracting? Hold on. What am I adding and subtracting?
are we subtracting now 110 with 5? So that'd be 105. And then we subtract it again.
Hold on.
That
Hold on.
makes it
So, okay. So at the standard at the second standard deviation, all I have to do is double the number.
yeah.
That's all I have to do. Okay. I was showing you the harder way, but the easier way is 110 plus and minus 10.
You said what?
110 plus and minus 10.
Oh,
That's
100.
all I need. Does that make sense though? What I was showing you on the bell curve, I was showing you the longer way. The fact is, it's 110 plus and minus 10.
Dog. Clap with me.
That makes
Ready?
sense?
Go. Dog.
I don't need the bell curve. I was using the bell curve to show you, but you don't have to go through all those steps. You just know at 95%, you double it. That's it. Okay. Everybody good with that?
Mhm.
Okay, so let's talk about then the standard deviation. The standard deviation is going to be the same sort of thing, but it's the group, not the person. Okay. So, Tamika, what do you think I do with this one? Read the question for me.
Which of the following scores is closest to the mean?
Okay. So this one, it asks about the standard deviation. So the standard deviation, there's no person involved. It's a score of everybody. Okay. So what do I do with this? I know the mean is 75, right?
Mhm.
That's in the middle. What else do I know?
The standard deviation is 8.
What do I do with that 8?
Do you even need that with this question?
You tell me.
I would say no.
Okay. So then what would my answer be?
It would be C 70.
So 70 is less than 1 standard deviation away. Absolutely. I could have done 75 plus and minus 8, right? I could have gone up and down the bell curve, but all it's asking me is which one of these numbers is closest to 75. That's simple. That's simple. I know.
And then you laughing at me.
No, I'm laughing because it's embarrassing, right? Like how easy it is.
Yeah,
I know. I've been doing this. So
that's
it's
why I'm laughing
embarrassing
too.
because you're like, why am I making it so hard? Why was I making it so hard in the test? Like, not that big of a deal.
It's all these extra words. Just ask.
So
just
that's what
say
we're
close
learning
enough.
is the verbiage. Now they're not all that simple. Okay. So let's keep going. So I will teach you the rest of the bell curve, but the goal is to remember is very few of the questions you actually need the bell curve. You need to know how it works and the facts, right? But you don't really need the bell curve. I'm going to introduce you to Okay, do you see my screen? Okay, so when we look at the normal distribution, this is the same information. It's got a little more information on it. Okay, so what I know, and again, this is just factual information of how we learn about the bell curve. What I said before is that between the 34, right? It's still going to be the 68 is still going to be the first standard deviation. So between here and here, this is still the 68%. Okay. This is still going to be the 95. And this will still be the 99. Okay. Facts. Okay. So what I know then is this is half of the scores. Like I said before, if there's 1,000 people, 1,000,000 people, it doesn't matter. This is always half. Z scores line up exactly with the bell curve. So it's a -1 Z score, it's a -2 Z score. It's the same thing as the bell curve. T scores I know are about 10. 10 is 50 is the middle, and they go up and down by 10. Okay. The stay 9 literally means stay 9. It's 5, it's 9 equal parts with 5 being in the exact middle. Okay. Percentage. So if you look at the score, the percentage, half of the percentage is right at the mean, the middle. Percentile means you go down one step. Okay. So the whole total score is 100. It's 100% of the people. 50% are going to be in the middle. The T scores and the Z scores, the Z score is 0. It lines up exactly with the bell curve. And the T score is my 10. Math just has facts. Okie dokie. Okay, so Kia, work this one out with me. What do I know? You can draw on this, by the way.
I know,
Pen.
I'm trying, how do you move your drawing options? Because it's for
Go
mine.
over and you click on that right here. And so if I click on that, it'll give me the pen.
Yeah. Oh, undo. Okay. Well, I'm trying to move my bar because I can't see the question. Can you move the question up a little bit, maybe?
I can.
Okay.
Is that better?
No, can you put it in the chat? It'll be easier for me then. Sorry.
No problem.
See?
Okay. There we go.
Okay. Says if a test has a mean of 100 and a standard deviation of 15, we know it says 95% of the test takers score between 70 and 30. B, 68% of the test takers scored between 85 and 115. C, 34% of the test takers scored below 85. Or D, 50% of the test takers scored between 85 and 15. What do we know? Mean is 100, that goes in the middle. Standard deviation of 15, so it's plus or minus 15. My answer would be D.
Okay, how do I know that?
When you're doing a standard deviation of 100, half of that would be 50, and then it's plus or minus 15 on either way.
Very good, very good, very good. So hold on. So how is B and D different?
B and D,
Mm-hmm.
they said the standard deviation, the test, it has a mean of 100. That's your first standard.
Okay, so let's plot it. Let's plot it. Okay, so 100 is here. And then again, we know this one, 85, 115. Okay, so is A true?
No, sorry.
So if we take this down to 70 and this up to 130, A is true. Isn't that true?
It's true.
Keep going.
I think it's a bad question because A is true. B is also true. C says 34% of test takers scored below 85. So 85 is here. Okay. So that's not true. And D is not true. So both A and B are true. That's just a bad test question. You see how I got there? Why those are both true? Yeah, that's just a bad test question. I apologize. Try this one. Okay. And attack that one.
Alrighty. Oops. Do you mind moving it over or adding it to the chat?
Not at all.
Okay. If a test has a mean of 75 and a standard deviation of 5, we know. So then it's the mean is 75 and the standard deviation is 5. Okay, we know A, 34% of the test takers scored above 80. We know B, 68% of the test takers scored between 70 and 85. 95% of the test takers scored between 65 and 85. Or D, 50% of the test takers scored between 75 and 80. So my 75 is gonna be what's in the middle at the 0.
Okay.
And then if I'm gonna do +5 -5, then +5 is gonna be 80. And -5 is gonna be 70. So it would be between 70 and 80.
Okay.
That would be for the 95%. I mean 68%.
Mm-hmm.
So then 80. So then B is not correct.
B is correct.
B is correct. Wait, hold on. 70. And then
You add and subtracted 5. So in the first standard deviation, B is correct.
I think 75,
Okay,
80,
so
68, 95, 99. So then 75 plus 5 is 80.
got it.
So then how is it between 70 and 85, Doctor?
Oh, I apologize. I see that. Because hold on, because 75 plus 5 is 80. So I apologize. That is
Yeah, and I'm doing
not
math in the air,
85,
so I'm just like,
not 85. You are correct. You are correct.
okay. So then that one's out. 95 is the second standard deviation. So we're doing plus 10 minus 10. So 75 plus 10 is 85 and 75 minus 10 is 65.
Okay.
And then because those are the two that are the standard deviations, I wouldn't pick the 34% and I wouldn't pick the 50%.
Okay. So how many people, correct, I apologize. I can count. I can count. See, it's the answer. So what percentage of people scored above 80?
What percentage?
So 80 is here, right?
Yes, it's at the standard. I mean, the second. So the 95.
So 75, the 80 is here.
Mm-hmm. It's at the,
80
so
is the
we're at the
first
second
standard
standard deviation
It's the
and we're
first
at
one.
95.
It's the first one, right? 75 plus 5 is 80.
I mean,
So
yes,
it's
I'm sorry. Yes, I'm getting
Okay.
confused.
So the question I ask you is how many people scored above 80? All I know is this very small percentage here scored before 80. It's like 13.9 and 2.14.
Mm-hmm.
So like 15%, 16% scored above 80. Does that make sense?
Yes.
Okay, because
And we're
80 is
going to add
here.
the 13.59 and the 2.14.
Absolutely. Those are the only people that scored above 80. A very small percentage.
Do a type of question like that again, please.
So I just ask her that just so you understand what that means. So the question, the A one was 34% of test takers scored above 80. And I know that 80 is here. Right? Because this was 75. So this is 80. So the only people that scored above 80 are here. So it's about 15% that scored above 80. It's the 13.9 and the 2.14. Okay, that's only a few people. So if it asked me how many people scored below 80, that would be all the people over here. I'm going the other way. Okay. That's all. That was just making sure you understand how the curve works. Now, hold on. Okay, we'll take it up a notch. Okay. Take this one, Kia.
Can you put the question in the chat, please? Oh, I see. Okay, I moved my screen around. I could see it. It says Noah and Olivia took a logic test with a mean of 70, a SD of 12. Noah's T equals 45, and Olivia's Z equals a plus 0.5. Who scored higher? Really? So, all right, so let's go with, what do we know? All right, so this is the mean, right? 70. So that would be in the middle. And the standard deviation is 12. Okay.
Okay. So I know for a fact, right?
Mhm.
Facts I know from the question. Okay. That the mean is 70. And the standard deviation is 12. So this is 82. This is 94. I can add, yeah. This is 70 minus 12 is 64. And this is 52. Okay, those are the facts that I know. Okay.
Right. Noah's T is 45. T is also standard deviation as well, right?
Okay. So the T is here.
Score is at the bottom. The T score
Okay.
is at the bottom.
So hold on. So so Noah's T score is 45, right? So that goes here. This is Noah.
Right. Uh-huh.
Okay. And Olivia's Z score was 0.05. That goes about right here. Okay.
I'm sorry, I'm so close to the table screen. And it says, okay, so A, Noah scored 64 and Olivia scored 76. B, Noah scored 76, Olivia scored 64. Noah scored 70, Olivia scored 70. There's not enough data. There's not enough data. And
So before I look at before I look at the chart, is there anything I can take out?
Take out? You mean from the answer?
Of all these, the A, B, C, and D, is there anything I can take out before I even start adding and subtracting?
C?
Yes, absolutely. Absolutely. That means I can take out D too. I'll take that back. I can leave D. Okay, so now logic tells me by looking at the map that Olivia scored higher, does it not?
Yes.
Okay, so That's the fact, right? So I know Olivia scored higher. So now I've got to figure out which one of those is true.
Well, when we're looking at the plus or minuses that we plotted out, Olivia is here. That means that she scored between a 70 and an 82.
Okay. So
And
she's like halfway between a 70 and 82.
right. And then Noah is on the other end. Between the 70 and the 64. So the answer would be Noah, B, right? No.
Hold on. We know
Okay.
Olivia. Hold on. We know Olivia scored higher.
Right.
So the answer is A.
A.
Makes sense?
Yes.
Shawty, I saw you smile. You got it. I saw you smile. You like, oh, this isn't so bad.
Yeah, it's not really. But look, I ain't gonna lie. I literally was thinking D because it wasn't even. Like the score was like Olivia was scored between 70 and 82. So I was thinking 76. And then Noah scored 64 between six, like it said 64. So I was like, but that's between it. So I was like, that's not enough data to me. But then you like,
It
hey, and I'm
is.
like,
If I know the standard deviation is 12 and she scored 0.5, she scored half on the way to 12, that's 6.
and that's why I had got like, okay, that's it. That's it.
So what makes it the hardest is that we have to learn this graph. We have to learn the bell curve and learn it so that we can answer these and be able to draw it when we get there.
Got it.
See, that's my biggest downfall. I'm not gonna remember all these numbers.
Okay,
You'll
so
get
you'll
it. No,
find
you
you'll
will.
find that if there's not that many questions on there, and a lot of this you can do in your head. Once you get used to it, you can do it in your head.
Yes, like I've got it down great, but I mean, I really like just kept on. I would draw it. My kid would quiz me. My husband would quiz me. I bought an expo board. And so I have this little expo board that I can carry with me. I took it with me when I traveled like to the hotel. Like I just kept on, and then I would do it in blue. And then when my son would quiz me, he would do it in red and I would take a picture and I would put a date. The next day I would draw it again, put the date, and he would do it in red. And I kept on. Y'all can do it. And then you're going to be like, oh my God, why am I even so stressed about this part? I need to be stressed about helping relations.
You will. Okay, Shadia, your turn.
Lamb and Amy took a retest. M equals 60, the ST is 8. So Lamb Z equals 0. Amy score is at the 16%. Who score higher? Right. So we know the medium is 60. And the SD is 8. So we add 68. And then we add it again. And then we subtract 60 from 8. See, I would need a calculator. I would need paper writing this down.
Girl,
I'm horrible at
you
math.
got fingers, and you get a board now. Come on.
That's 52. Yeah,
Okay.
yeah. I actually
Okay.
did in my head. Okay. So Lamb scored 0, Z and 0. So she's at already 60. And Amy scored 16 percentile. 16 percentile is all the way on the opposite of the left hand side. So
Did
who
we
scored the
did we
highest?
take these out?
Huh?
Did we
Yeah,
do all the rest? We do 68 all the way up, or are you gonna leave it there?
My scarf has.
We leave it there. Because if we look at the percentile, she haven't even passed the mean.
2, 3.
Amy
Dang,
hasn't even passed the
girl
mean.
knows some stuff, don't you?
So who scored the highest is, of course, is Liam.
Very good. Very good. Very good. Everybody get that?
1,
Did you need the bell
2.
curve for that?
3.
No,
Not at
No.
all. Not at all. Not at all.
once we get the mean
Mm-hmm.
and we remember where the percentile is
Mm-hmm.
here in the Z, we got it.
Okay, so remember that the 50th percentile is the middle. If I go down one, it's 34, right? And if I go down one more, that is my 13.9. So right below the 34 is my 610. Oh, it says 15.9, but that's where it is. Okay.
Dr. Pam, is there, if I remember when they ask us to identify which standard, like first standard deviation, second and third in questions, do we have time to go over a question like that where they ask us to identify which is which, or is it that simple? You just know the numbers.
You just know the numbers.
Okay, the 68, the 95,
Uh-huh.
99.
It's just a fact.
Okay.
Just a fact.
All
And
right.
then if it asks you, so it'll ask you like the 68, 95, 99, or the 2/3, which is 68. So it'll
Okay.
ask you either which way.
I remember seeing though, like pick which standard deviation is which, and I'm like, but it's in a word, it throws you off. So I didn't
So
want to
you'll
be,
know first, second, third.
yeah,
68, 95, 99.
got you.
And then just remember that 68 and 2/3 are the same. So don't get freaked out.
I'm not trying to add anything new today. I'm just trying to keep going over what we've just learned already. Just looking at it different ways. Okay, Tamika, what do I do with this question?
Number 6, a test is considered highly reliable. What effect does this have on the standard error of measurement, SEM? A, SEM increases. B, SEM is unrelated to reliability. C, SEM decreases. D, SEM stays constant. I think if something is reliable, then it's consistent. So I would go with D, SEM stays constant.
Okay. So the SEM, okay, so what's the question asking me?
What effect does this have on the standard error of measurement?
Okay, so the standard error of measurement is the amount of human error that might be in the questioning. Okay, so normal IQ is 100. So I know that if somebody scores 85, that because of testing environment, testing something, right? That they really may be at 100, but we give them a few points just because of possible error in testing. Okay. So if it's very reliable, that means there's less error in testing.
Right. So I guess it would be C then. The SEM, it would decrease.
Absolutely. Absolutely. Okay. So it'll go down. So the higher the reliability, the lower the SEM. That makes sense?
Yes.
On that same kind of vein, then. That question. Take that one. Take that one, Kia.
Question is, which test situation would result in the lowest SEM? A test of reliability of 0.50, test reliability of 65, a test reliability of 80, and a test reliability of 95. All points. You said the higher the reliability, the higher the SEM. So that would be, you just said the higher the reliability, the higher the SEM.
The higher the reliability, the lower the SEM.
The higher the reliability, the lower SEM.
Hold on, I put it in your chat box. Okay. So higher reliability means the test measures consistently with little random error, because SEM represents error. When reliability goes up, SEM goes down.
Right. So the highest score in the choices would be 0.95. So I'm going to go with D.
Got it. Does that make sense?
Yes. But it wouldn't have if you didn't say the higher the reliability, the lower the SEM.
Okay.
That was the chef's kiss. Thank you.
Shadia?
A test is considered high reliability. What effect does this have on the standard error of measurement, SEM? So when it's high reliability, it's lower the SEM. So that means it's C, the SME decrease.
I wish I could
Say that
play
again?
with Miss Keisha more.
It's C, the SEM decrease.
What? I wish we could sing together.
If the reliability is 0, is 100, what's my SEM?
Doctor, I think she's reading from the screen, not the chat.
Oh,
Oh, I'm sorry. I'm
Oh.
sorry. I'm sorry. I'm sorry. I'm sorry.
yeah. I will read from my bad.
No.
There we
go. There we go. There we go. Sorry.
If the test reliability is 1.00, the SME is 1.00. European possible to calculate is not, we're gonna take out D. And we're gonna take out C.
Okay. If it's got perfect reliability,
Ain't that mean it's B, 0?
there's no error. There's no error at all. If it's got perfect reliability, there's no error. Okay.
So it's A0.
Yeah, no
It's
error.
Perfect.
Perfectly reliable, then there's no error. Okay. How's your brain feeling today?
Empowered now.
Mhm.
Not so bad. Not so bad. We got some more to learn, but not so bad. Okay, get all the notes out of the chat box. And we will continue next week with learning some more things. Not so bad, I promise you. Okay. Everybody got everything? Okay, watch this video a couple times. We'll just keep going. Easy points. Easy, easy points. I promise you, there's a reason why we save it to last. You just have to memorize the facts. Okay? Bye, guys. Pat yourself on the back. You did the hard stuff.